to deal with this differential equation, today I want us to see how we can deal with this differential equation, getting its general solution. Now, if you clearly see, this one is a linear differential equation. So what do? It's linear, but there is some small trick here that we have to see, that x is on dy by dx. So we have to first divide throughout. So we divide throughout by x, we shall have dy by dx minus y out of x will equal to x out of x minus 1 times 1 out of x that we have divided throughout. So this can go with this. So we have our dy by dx minus y out of x is actually equal to 1 out of x minus 1. Now, when we say that this is a linear, it obeys the form. The form is dy by dx plus py is equal to q. So it obeys this form. Therefore, we can go ahead and identify p from here. So when you identify p from here, our p is actually negative 1 out of x. Yeah, if you compare. So we can go ahead and get the integrating factor. The integrating factor is an exponential integral of p dx. This tells us that we shall have an integrating factor as an exponential integral of negative 1 out of x dx. So therefore, we can see this as our integrating factor becoming exponential negative ln of x. So after seeing that, we can go ahead and take this negative 1 up. So we have integrating factor as e of ln of x to the power negative 1, which eventually becomes x to the power negative 1 according to laws of logarithm, and this gives us our integrating factor as 1 out of x. Now, after having it as 1 out of x, we have to multiply it throughout to the differential equation. So we go ahead and multiply it throughout. Now, where are we going to multiply it throughout? We are going to multiply it throughout in this simplified one. So we shall have 1 out of x dy by dx minus, how we multiply it here, it becomes y out of x square is equal to, now when you multiply it this side here, it becomes 1 out of x into x minus 1. Now, we agreed that whenever a linear differential equation is simplified on one side, it becomes exact. So this side here becomes exact. So you can know where it originated. Yeah, if you haven't seen my video about exact differential equation, I'm going to link it here such that you can go and see it. So cheap work. So this one came from a dy out of x with respect to x is actually equal to 1 out of x into x minus 1. So it came from this. When you differentiate this, you actually get this when you differentiate this. So the next thing we do is to integrate on both sides. So when you integrate on both sides, integral with respect to x dx of y out of x, we are integrating with respect to x, will be equal to the integral of 1 out of x into x minus 1 dx. So therefore, we can see it clearly that this will turn to be y out of x is actually equal to the integral of 1 out of x into x minus 1 dx. Now, when you clearly see this, this is a partial fraction. So we can integrate this using partial fraction. So we first decompose it and then integrate it. So we first pull it out. So 1 out of x into x minus 1 can actually be, if you clearly see, this is a linear differential equation here. If you haven't seen my video about differential equations, I'm going to link it here, and then you can also see it. So is the thing. So this is the linear denominator with the linear factors. So we can go ahead and decompose it as a out of x plus b out of x minus 1. So we can get the LCM and simplify. So 1 is equal to is identically equal to a into x minus 1 plus b of x. After having that, we can begin to assume the values of x that can make 1 0. So we can say if x is equal to 0, so if x is equal to 0, we realize that b goes to 0. b automatically goes to 0. So we shall have 1 is equal to a into negative 1 plus 0. So this gives us a as negative 1. We continue and say if x is equal to 1, a will go to 0. So we shall have 1 is equal to 0 plus b, giving us b as 1. Yeah. Now if we put it back here, taking a and b back here, we have 1 out of x into x minus 1 is identically equal to negative 1 out of x plus 1 out of x minus 1, like that. Now after here, we can put them back here, and then we integrate. So on integrating, our y out of x will actually equal to, which was the integral of 1 out of x into x minus 1 dx. We can have y out of x is actually equal to the integral negative 1 out of x dx plus the integral of 1 out of x minus 1 dx. So our y out of x is actually equal to negative ln of x plus this one is ln of x minus 1, then plus a c. But that c can be ln of a constant. So that c can be ln of a given constant. Why? Because they are all ln. So it's a ln of a given constant. So arranging, so we can see that y out of x is actually equal to, doing some simple rearrangement here, minus ln of x plus ln of k. So ln obeys laws of logarithms. So we can finally have y out of x equal to, now this is the same as ln k into x minus 1 out of x. Okay, so therefore our aim is to get the value of y, because that's the purpose of simplifying. So multiplying this on both sides and multiplying x on this side, we shall have y is equal to x ln of k into x minus 1 out of x. As simple as this. Now after reaching this point, you are able to have solved the differential equation and you have defeated the number. Yeah, please don't forget to subscribe if you haven't subscribed. Yeah, subscribe, share, because sharing is caring, like and comment. Where you have issue, we meet in the next. Thank you so much.